Good morning, grade 7. We'll be doing set 12 today. That is find HCF or GCD. Now what do you mean by HCF? Highest common factor or greatest common divisor. Either 2 or 3 numbers are given and you have to list all the factors. Factors means what? For example, 25. So 5 is dividing 25 completely. So 5 is factor. Like this you list all the factors of both the numbers. Then see which are the common factors. After pointing out, see which is the highest or greatest common factor. That is to find HCF or GCD. Okay. Find out the greatest or the highest factor which is dividing both the numbers. Okay. So there are 3 methods by which you can find HCF. See first now 25. This is the horizontal method. You write 25 can be split as 5 into 5. 40, first you can split 40 as 4 into 10. 4 again can be written as 2 into 2 and 10 can be written as 2 into 5. So at the end we get 40 as 2 into 2 into 2 into 5. So in our earlier set 11 we have seen how to factorize into primes. Similarly, I have factorized these two numbers into primes. And now find out which are the common factors. So we can see in this example, there is only one common factor, 5 here also and 5 here also. Okay, so highest and lowest, here the question doesn't arise because there is only one common factor. So as it is, HCF means nothing but common factors. You find out, take out the common factors if there are 1, 2, 3, how many ever they are. Multiply and find out the answer. Now you will come to know in the next problems where more than one factors are common and then I will explain at that time. As of now, to this, let us stick to this problem. Here only 5 is common in both 25 as well as 40. That means 5 is dividing 25 also completely and 40 also completely, and therefore HCF is nothing but common factors. Here common factors are not there, only one factor is there, and so 5 becomes your HCF. Another method is to write 25 and 40 separately and do carry out the prime factorization. 5 5s and 5 1s are, okay, yesterday we have seen this. 40, 2 if you divide 40 by 2 you get 20, 20 divided by 2 you get 10, 10 divided by 2 5 and 5 1s are 5. Now write 25 is 5 into 5, 40 is 2 into 2 into 2 into 5 and here 5 5 is common, so HCF is 5. Alright. Now third method. Take both the numbers at a time. And here you have to choose the prime numbers which are dividing both the numbers at a time. See, if I take 2 over here, 2 is dividing only 40. It is not dividing 25. So I am not allowed to take 2. If I speak with 3, 3 is neither dividing 25 nor 40. So which is the next prime number? 5. 5 is dividing both the numbers, 25 also and 40 also. So 5 5s and 5. 8s are 40. Again this it can be divided. But if you start over here, 5 will be divided by 5. It can't divide 8. If you choose 2, 2 will be dividing 8. It can't divide 5. So there is not a single number now which can divide both these numbers. So I have to stop here. And my HCF in this case is this number, 5. I hope 3 methods are clear. Now let's do another problems also. You will understand. I am going to follow this method because at a time you get factors over here and you can immediately write what is HCF. Okay, let's look at the second problem, 56 and 32. So by 2 both numbers are divisible. By 2, 28, 16. Okay, again 28 and 16 both are divisible by 2. If we divide this both by 2, 28 divided by 2 is 14, 16 divided by 2 is 8. 14 divided by 2 is 7, 4 divided by 2 is 8 divided by 2 is 4. Afterwards, we can't carry out division. Why? This is divisible by 2, but this is not divisible. This is a prime number. So, we have to stop. Always remember, you have to choose such a number that it is dividing both the numbers at a time. It is only dividing one number, that will not do. So, all these numbers which are over here, they will be product of these numbers will give you HCF. And so, you have HCF as 2 into 2 into 2, that is 8. Now, look at this problem. 40, 60, 75. You can't divide all this by 2, 75 is not divisible. You can't divide them by 3, 40 is not divisible. So only option was 5. So divide by 5. After dividing we get 8, 12 and 15. Now look at these numbers. These two are divisible by 2 but they are not by, but 15 is not divisible by 2. If you go for 13, 3, these two are divisible by 3 but 8 is not divisible by 3. Next prime number is 5. 15 is divisible by 5 but 12 and 8 are not divisible by 5. The next prime number 7, nothing is divisible. Okay, after 7 you have 11. Now 8 is already smaller, so you have to stop over here. So only number which is dividing all the three numbers is 5 and so HCF will be 5. Interesting example is 4th, 16 and 27. Look, factors of 16 are what? 2 into 2 into 2 into 2. 27 is 3 into 3 into 3. Can you see anything common in both of this? No, nothing is common. If nothing is common, then HCF is always 1. Please remember this. If there is no common divisor in both of the numbers, then their HCF is 1. Okay? So, any two co-prime numbers, nothing is common, no, only 1 is common. So, always co-primes will have HCF 1. Remember like that also. Now, look at 5th problem, 18, 32, 48. All these three are divisible by 2. Then we get 9, 16, 24. Now, 9 is divisible by 3. 24 is also divisible by 3. But 16 is not. 16 is divisible by 2. But these two are not. No, none of these are divisible by 5. None of these are divisible by 7. After 7 direct 11 where 9 is small. So you have to stop here. So HCF is nothing but 2. Look at the 6th problem, 105 and 154. Try with 2, 3, 5. Both the numbers at a time they are not divisible by 2 or 3 or 5. Individually they are. This is individually divisible by 2. But at a time it is not, 105 is not divisible by 2. So you can't use 2, 3 and 5. So option remains is 7. After dividing these numbers by 7, you get 15 and 22. Now look at these numbers. This is not divisible by 2. This is not divisible by 3. This is not divisible by 5. Both are not divisible by 7. All prime numbers I am telling you. Now 11, 22 is divisible. 15 is not divisible. Next number is 13. Alright. So if you go on like this, none of the number we are getting which is dividing both the numbers. And so we stop and HCF is equal to 7. I hope you are understanding. Let's look at another examples. 7th one, see, 42, 45, 48. All these three are divisible by 3. Afterwards, all these three are not divisible by any common number. So we are stopping over here and therefore HCF is only 3. You can see these two are divisible by 2, but 15 is not divisible by 2. This is divisible by 3, but these two are not. This is divisible by 5, but these two are not. None of them is divisible by, only 14 is divisible by 7. These two are not. Then comes 11. None of them are divisible by 11. None of them are divisible by 13. And afterwards, the number goes above 13. So next number is 14. So we have to stop over here. Now look at the 8th problem, 57, 75, 102. By 3 all the numbers are divisible. You get 19, 25, 34. Once you get 19, 19 itself is a prime number. So it will be divisible only by 19 or 1. And these two are not divisible by 19. So we have to stop here. HCF is 3. Now 56 and 57. While teaching co-primes, I told you 2 consecutive natural numbers are always co-primes. They will have only one factor in common and that is 1. So always remember, whenever 2 co-prime numbers are there, their HCF will always be equal to 1. See the factors of 56? 2, 2, 2, 7. 2 into 2 into 2 into 7. 8 sevens are 56, isn't it? Now 57 you can get 3 into 19. Is there anything common in them? Factors of these are 3 and 19 and 57 itself and 1. Factors of 53 you can see 1, 56, 2, 4, then you can have 8, 7, 14, then 28, like this you can see. Alright, but common between them, nothing is there. And therefore if there is no number which is common divisor, their HCF will always be equal to 1. Now coming to 10th problem, first all of them are divisible by 3, then all these are divisible by 7. After dividing them by 7, we get 37. 37 is prime. Now it will not be divisible by any other number. And therefore we have to stop. And so 3 into 7, 21 will be your HCF. So I think it's quite clear how to find the HCF now. You can follow any method. There is one more method, that is by division. We will see it into the next video. Thank you.